on Docker images. The question will always arise. We have been pulling images from Docker Hub, and we have been using. In fact, if I come up to my terminal and I say Docker images, what will I see? I will see tons of images that I have pulled from Docker Hub. I have pulled PHP from Docker Hub, I have pulled Tomcat from Docker Hub, Ubuntu, and the rest. These are images that I have pulled from Docker Hub. The question is, why should I then, these images are in Docker Hub, why should I then struggle to create my own images? The first reason why I should want to create my image is that, number one, to make my process in the company go faster. What do I mean by that? You can be in a company where your process, your daily job will be to create an Ubuntu container which has Maven installed inside it, Git installed inside it, and updated. So when you come to the morning, imagine you are coming every morning, you have to create a container, and that container is supposed to have, the first thing is the container should be updated. That's the very first thing. That container should be updated. And then the second thing is that that container should have Git installed, and that container should certainly have maybe Maven installed. This is what you are supposed to come and do every morning, every blessed day. Okay, when you come in the morning, you spin up a container, you update it, you install, you update. What do? You install Git, and then you install Maven. Right? This is your duty. Come in the morning, spin up a container, install, update it, install Git, and install Maven. That is what you have to be doing every morning. Now, let us do this job and see how it is, and see how time consuming the job can be. We want to install, we are going to pull what type of a container? We are going to pull an Ubuntu operating system. We are going to pull an Ubuntu operating system and install it. When we install it, we are going to update it, and then we are going to install Git inside, and then we are going to install Maven inside. Okay, that is what we want to do. So let us go to our system, pull our Ubuntu, and enter into interactive terminal in the Ubuntu. Okay, we are in our system right now. Let us follow our notes. Okay, the first thing is, this is our first command. We are going to run docker run --name. C11 will be the name of our container, and we want to run it and enter directly into a interactive terminal. So we are going to be pulling the image Ubuntu. We all know these formulas. So we are going to run the docker command --name our image, our container, and enter interactive mode, and we are going to be pulling the image Ubuntu. So let us run that command. So what is Ubuntu? Ubuntu is like an operating system existing in the form of an image, and we are going to install, it's like installing Ubuntu inside Ubuntu. This is what we are doing. you understand that Docker is a containerized system. So we have Docker, and then inside the Docker we have an Ubuntu system hosting Docker, and inside the system we are going to again install an Ubuntu system, which inside the Ubuntu system we are going to now install these various systems inside, like that. So inside the Ubuntu system we are going to install an Ubuntu system. So that's what we are struggling to do. I hope my system is not failing. Let's just give it some time to install, please. I'll kill it. Yes, Mr. Kiba.
I'm the one, sir.
Yeah. Okay, Declan, go ahead.
What is the essence of pulling Ubuntu or running Ubuntu inside Ubuntu? While we are already inside Ubuntu, what is the essence of pulling another Ubuntu operating system? Why not run the or install the Git and the rest and Maven immediately? Or why need to pull another Ubuntu operating system?
You know your shady type of things that you do in operating system. Look like Adija has already crashed down his own Ubuntu. If she had to do all those configuration that she was doing, but inside a container, after doing all those configurations, she could terminate the container. It's better to practice inside the container rather than inside your original Ubuntu. When you finish practicing inside the container, you terminate the container. Your original Ubuntu is there without any harm. Hmm?
Okay, okay, I understand.
Because you will not be each and every time trying to trying to mess up with your Ubuntu. It does not go. What am I getting? The container name C11 is already existing. There is a container existing called C11. So let's see. Docker ps hyphen a. That means the container was installing. This is it. So let us cancel it again. Okay. We are expected to run the container and enter into the container. Okay, we are inside the container. So the container has run. Okay, and we are inside the container itself. As we did precise that we wanted to go into interactive terminal. So the container has run. We are inside the container. So where are we? We are inside this place right now. So the first thing we want to do there is that we want to update the container. So we run apt get update, right? We update the container. Container is highly updated. The next thing is we install git apt get install git. Yes. So Git is being installed. Brace yourself and be ready to wait, because Git installing and Maven installing is not going to be something that will happen in a twinkle of an eye. So you have to be waiting and waiting and waiting for it to install. Remember where we are. Don't lose focus. We are in our container. Inside here, we have updated the container. Now we are installing Git. After we install Maven inside this container. That's what we want to do.
Mr. Kiba,
Yes, hi, Mr. Tiklan.
any update on the assignment?
Yeah, regarding that assignment, as we were discussing previously,
Uh,
I was thinking there will be no class today, rather tomorrow. So I wanted to use this evening to practice what we were discussing. But I think tomorrow I'll try to put it in practice.
okay, okay.
Yeah,
I would like to see the your own code.
the outcome. Yeah, 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 yeah.
I would like to see your own code, the code, the YAML, right? The YAML file. I
Mm-hmm.
would like to see it.
Yeah.
Yes,
Okay.
how you
Yeah,
went about your credentials.
you you remember what we said, that maybe in the Docker Compose file where we are going to increase a line under talking about credentials.
I didn't mind, so I don't know.
Mm-hmm.
I would like to see yours. You know what?
Okay, once I do it, I will let you know. Maybe tomorrow morning, first thing early
Yes,
before eight
because
o'clock
yeah, I wasn't able to build
to
to build
deploy.
my code to deploy, build and deploy.
Mm-hmm.
Yeah,
But
I
I saw
was able to download the code from
and
my
build.
Git,
Yeah.
but to build was failing. So that is
So
a problem I have.
yeah. So that means the credentials of Tomcat finally was not created.
No, as for the credentials, I don't. You cannot tell, but I think they are okay.
Mm-hmm. Okay.
Yes,
Anyway,
they are okay.
when I'll start practicing in the morning, I will let you know, man.
I know the kind of money people always use. It's 3 a.m. in the morning. I'll see a message from you. But I'm snoring.
No, no. Tomorrow you will see a message around, let's say 7 o'clock Cameroon time. I will not be that early.
Okay, I'm used to seeing it at 3 now. We'll see how we can do that.
Uh, yeah, 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 yeah.
So you should learn to be working across different time zones. That is also one aspect of this working from doing télétravail, as we call it here in France.
Okay.
Okay, so yeah, this is really teletravel, working in a distance.
It is important to know how to cut across time zones. Sometimes you might be working from the US or in the US, but in Africa or in Dubai or elsewhere, you have to get up and work in the night. So those type of time zone stuff should learn and try to master it.
Yeah, that's
Yeah,
true,
so
sir.
that's true.
So we are installing presently. We are installing Maven, and Maven for Maven to install, Java is going to install. So the unpacking is going on.
Java and OpenJDK.
Yeah.
So Declan,
Yes, yes.
what I'm planning to do, I'm thinking of once I finish executing my Docker Compose file, I want to cd to Tomcat. When I'll cd to Tomcat, I will run ls to find the files inside. Then once I
Ah,
see that Tomcat hyphen user.xml file, I will run a nano. I will nano that file. That is edit.
you mean you CD to Tomcat?
Yes, that is what, and that is my plan work. The kind of work I'm planning to do in order to
Your
be
plan
able to,
is
mhm,
your plan is your plan to see.
to
Are you
to
planning
to.
to see the logs of Tomcat, or you are planning to CD?
I'm planning to cd Tomcat, then feed the credential. That is the username and password into that .xml file. So that is what I will do first
Because
of all. Mhm.
once you're running the YAML file,
Yeah, yeah.
you're already in your credentials there. There's no need to CD. For me, I don't see any need to CD into Tomcat before putting the credential. I don't know. I
Mhm.
don't know. It might be correct, but I've not
Yeah,
tried
that
it.
is just a suggestion now because you remember you didn't deploy. So I'm thinking maybe the credentials you will place under the Docker Compose file didn't link up with Jenkins. That is what I'm just thinking. So I want to do something different.
Ah, okay. Okay.
Anyway, we'll just try, man. I will try this and I will try the other one
Yeah.
as well.
Okay. Yeah. Yeah. Yeah.
Yeah.
Is Adija still in this class?
She just left.
What about Renee?
Yes, present.
I don't like your silence, Renee. This your silence is making is might make you go back. Always try to interact and ask what is happening, what has been happening, how can I get in. It is very important. It is very, very important. Ever since you joined the class, even to say greetings to people, you have not greeted anybody, and you have not responded to anybody's greetings.
Good evening to everybody and to you, sir.
Yeah, this is now you are greeting. Just imagine.
Yeah. Hi, Mr. Rene. Good
Good
evening.
evening, sir.
Yeah. Good evening,
Yeah.
sir.
Adija, what happened that you left?
So I don't know what happened. Oh. The thing just shut down.
Choir practice.
So you took the lead today, now, sir.
No,
The ministry is going international.
So we'll be
Ministry
connected
has got
with just listening but to your own choir. So.
no, I work with some choral music behind to drive away sleep and keep awake.
yeah, yeah.
Some of these things like this,
Ministry is removed.
some of these things like this, from morning till night you are pressing buttons and pressing and pressing, and if you are not careful, you will sleep and be dreaming only how you are pressing buttons.
So and it's not a lie.
Yeah, that's true.
All right, finally we are done. Okay, what have we done? We have you all saw the time that we took, right? You saw the time that we have taken to just do what? To just install Ubuntu, update it, install Git, and install Maven, right? So right now, if we come to our Ubuntu, we can now run mvn hyphen version. We are going to see that we have Maven installed there with Docker installed there, and if we run java hyphen version, we are going to see that we have Java there installed. Everything is up and running. Now imagine that you did this on a Monday, and when you finish working on a Monday, because you guys want to do some cost reduction or whatsoever, you terminate all the containers and then you go home. Come on Tuesday, you have to do this. Come on Wednesday, you have to do this. What is it? That is not, it does not make sense, right? So what you have to do is you just have to create an image that has all these things already installed. Create an image that has all the various components that you have already installed inside them, so that when you launch that image, all these things now get automatically the image come with everything already installed. So that is why we are saying that there are two ways of creating that image, and we are going to look at the first way, which is using Docker commit. That's the first way we are going to use, using Docker commit. From Docker commit, you are able to launch an image. How does Docker commit function? You launch an image, the image creates a container, you update the container, you install everything that you want to install in the container, then you launch a command that will transform now this already launched container into an image. What are we trying to do? We are trying to walk away from, you have an image, and then let us put an image. We have an image, and then from that image we got a container, and then we configure that container and put things that we want inside the container, right? We put everything that we have inside the container, and then from the container again, we take now this container and then we create now another image from this container. Now what is the difference between this image and this one? This is image A, and this is image B, right? Image A is the original image that was in Docker Hub. Image B is your own image now that you are having. So what will happen with this image B? The next time you deploy this image B, what will happen? It will create everything that was already inside here. So image B is going to run with everything that was created inside here. Why? Because you created image B from container A. I hope I've not made the thing confusing here. You have image, original image. This is the original image from Docker Hub. This one is original. And then from that original image, you created a container. And inside that container, you install things inside. Then from this container, you created another image B, which means this image B is already coming with all those things that you installed inside. So that when next time you execute image B, it is going to create a container with everything that you already installed. Okay, that is the idea behind here. So what we have just done is we have taken the original image, we have installed it, we have already put everything that we want that should be inside. The next thing we want to do now is we want to take the image and then we create our own. We want to take the container and then we create our own image from the container. Okay, So that's what we are going to do, and we are going to do that using a command, and the command is called docker commit command. So what is the command that we are going to run? Yes, anybody has a question? Declan. Your question?
Yes, sir. Yes, sir. That is to say you are pulling.
I can't get you.
Yes, sir.
Yeah, you are on. Go ahead.
Is anyone getting me?
Yeah, go ahead.
Yes.
Yes,
That
we are
means in a
getting you.
nutshell, you are pulling an image from Docker Hub, and in that image there is no how can I put it, environment variables. Is that okay?
That you are pulling an image from Docker Hub, and
Are you
there's,
getting me?
yeah, I'm getting you. I'm getting you. Listen, what is your problem? What is your worry?
And there, like, it is empty. Yeah. Yes. I'm just trying to understand.
Do you know what
I'm
Ubuntu
just trying to
is?
understand why is it there, sir, or what we are trying to do.
Do you know what Ubuntu is?
Like, you're pulling an image which in itself is not having Git, is not having Maven, and when you run it, uh, pardon, sir,
It seems like we are having
some
a
sort of an operating
we're
system,
having
as you said.
it seems we are having a lack of communication. Okay, yeah, that is what you are saying. It is not some sort of an operating system. We all know Ubuntu is an operating system, right? You don't talk like you are not an IT engineer. Ubuntu is an operating system. If they ask you what is Ubuntu, you should not say some sort of. It is an operating system, a flavor of Linux, which means it is an operating system that can run on a computer, right? Am I clear?
Yes, I'm getting you.
Good.
Yes, sir.
Good. If you pull an Ubuntu image and then you install in Docker, what do you have? If I pull an Ubuntu image and install in Docker, what do I have? I have an operating system.
An image, sir.
An operating system. Don't look at these images, things like there are some trivial things. It is a full-fledged operating system that I have within my Docker. And in your computer,
Okay.
you have a Windows 10, right?
Yes, sir.
Yes, it's like saying that when you have a Windows 10, is there Microsoft Office installed inside when it comes new? Is there any Microsoft Office installed inside? No. Is there any VLC player installed inside? No. You buy your machine, you install that operating system before you start installing all those other things that you want to be using, all those other tools that you want to be using. Not so. Now, what if there was an opportunity for you to just buy or install a Windows operating system that already has everything that you want? Wouldn't that be cool? You don't need to install the operating system before you start installing other things. Is that not great? So that is the exact thing that we
Actually, yes, sir.
That is the exact thing that we are trying to do here. We are trying to install Ubuntu, but we want to install Ubuntu with something like Git already installed inside and something like Maven already installed inside. That's what we are struggling to do. Okay? Okay, this is the command that we want to run. We want to run the docker commit command. Our container is called C11, right? We are going to run docker commit, and then we ask C11, which is the container that is running, to be transformed into an image, and we are going to name this image now my Ubuntu. The original image is called Ubuntu. So this one now is my Ubuntu. That means now that the my Ubuntu image will contain now Git, contain now Maven, and will be updated. Okay. So we are going to run docker commit C11 my Ubuntu. so that we can transform now the container that is running into an image. So we run it here. No, not here. What we do is we exit without closing the container. We are inside the container right now, right? So we exit the container without shutting it down. Okay. So run docker container docker ps-a. We discover that the container is up and running. Our container is C11. So what we'll do now is we'll run docker commit C11 my Ubuntu. So we are committing C11, which is a container. We are committing it to an image. We run our command. So our image is being built. Let's just give it some time for it to get built. And make sure we run the right image. Okay, our image gets built. You see now our image is built. If I run now here, if I run now docker images, you will see the image that we have just constructed. Okay, we are going to see the image that we have just constructed. We will see the original image. You see, this is my Ubuntu here. This is the image that we have just constructed now. But this is Ubuntu, the image that we pulled from Docker Hub. So these two images now are different images. The next time, if I want to install an image, I don't need to install this one again, because this one does not have Maven, it does not have Git, it is not updated. What I want to install now is I have created my own image that has all these things already installed. Okay, somebody has a question? It's like I stopped sharing. Can you get me again? Okay. Let me try to see if I can
So we
restore.
cannot see your screen.
Yeah. You can be asking a question while I'm trying to resolve that. Yes, go ahead. Your question. Who had a question? Okay, we go ahead. So the next time I want to
So I cannot hear you.
Am I audible now?
Yes, sir.
All right. Somebody had a question?
Yes, I have a question.
Yeah.
Okay, so from my understanding, this my Ubuntu is now an image like with a complete package. So where will this image be stored in Docker Hub still?
If you want to keep, why will you keep it in Docker Hub? It is your own image that you have created. It is stored inside your computer. Why will you keep it in Docker Hub? Except that you want to share it to who need it. You created the image and customized it for yourself, for your own need. Who will need
Okay,
it?
sir. Okay, I understand now.
Right? Nobody
Yes,
needs
sir.
nobody needs it. Different people need their own images in their own way, so you keep it in Docker Hub for who to come and use it. So you
Okay.
you create this just for your own usage. It is like now it is inside my computer, right?
Yes, sir.
The image is inside my computer, so I can only use it within my computer. So it is just like you said, a full package. Yeah, not a full
Mm-hmm.
package, but my own customized image.
Okay, sir.
So the next time now, remember how we launched that image and we had to update and do all those things. This time around, we do not need to launch and update. We just need to run my Ubuntu directly. So if we run Docker
Docker
run
start my Ubuntu. Okay, Docker run.
hyphen
Yeah.
hyphen name, which we can pass the same name, my Ubuntu, right? And we enter interactive mode, and then we run the image, which still is my Ubuntu. I hope we understand this. And then we run it with a bash shell command. I hope this command is well understood. Docker run hyphen name, my Ubuntu is there, interactive terminal, my Ubuntu. So we give the same name to the container that we want to run as the name of the image. Okay, and we are entering the bash terminal. So let's see how this one is going to execute, whether it is going to execute it or it is going to fail. Let's watch and see. So instead of coming every morning and running, pulling images, updating them, installing dependencies, why not just customize an image that when you come in the morning, you just run one command and everything gets installed inside that image. It is more better like that. I mean, it makes your work faster. But this is not the only reason why we should build customized images. This is not the only reason why you should build customized images. Customized images are built because you would have to be generating your WAR files, your jar files, and you need to be dockerizing those files. So we'll see how you are going to be doing that. All right, you see, we are already inside. Did we still go through all the various hurdles that we went through? No. Now inside this container, we can run mvn hyphen version. You will see that Maven is installed inside the container without any problem. That is Maven installed inside the container. Okay. Yes, Declan.
So I would like to understand better why bash you included bash there.
What is bash?
On that,
What is bash?
It's a language that that image will understand.
Thank you very much. It is a language. It is a Linux utility language, right? When you have bash, then you can run things like apt get. You can run things like apt install. You can run the apt commands. You can run ls. You can run Linux commands using when you have the bash language. Bash is a language that Linux understands, right? Linux also understands shell. This is a shell language that Linux really understands. So once you are going into the terminal, make sure that you will be communicating with the terminal through a particular language, and that is why I include the language which I will be communicating in the terminal. Some they'll need a shell language for you to enter there. Some you need bash / bin and all the like. Okay. Is it clear, Declan?
Yes, it's clear. It's clear.
Okay, so we have finished with the first method. So I believe you guys will be able to launch a container, make changes inside the container, and save the container as your new image. And then I want to see a container which contains just everything which you need, but you are executing just one line and all those things are running. Okay. That is the first way of customized images. The second way of customized images is building an image from zero. Okay, what is this? That is, you have run your CI/CD pipeline. Whenever you run a CI/CD pipeline, what happens? What is the final result of a CI/CD pipeline? Who can tell me? What is the essence of running a CI/CD pipeline? What is the final result of the pipeline? What do we want? What is the aim of a pipeline? What is the final product of a pipeline? Yes, Mr. Edwin.
Yes, so let me just try. The aim of a pipeline is like to automate the system so that we have our our application running in case of any error in the delivery. This can be corrected. It's like a circle that is running automatically, sir.
Question is, what is the final product of a pipeline?
Our application, sir. Our application delivered.
Our application delivered in what form?
An artifact. So
The final product of a pipeline is the production of an artifact. I said this over and over and over. The final product of a pipeline, when a pipeline runs, at the end of the terminal of a pipeline must be the production of an artifact. If we don't have this artifact like this produced, then what are we doing? Okay, we know the essence of the pipeline is to produce this artifact, but the pipeline helps in producing the artifact faster. So the pipeline just helps in producing this artifact faster rather than traditional means. It's like talking about taking an airplane and taking a bicycle. The old means was taking a bicycle, but the pipeline is taking an airplane. You go faster, all right, and in real time. So pipeline, the final product of a pipeline is production of an artifact, and this artifact is mostly produced in what format? Mostly sometimes a jar file, sometimes a WAR file, right? Artifact can be produced in any format, okay? Jar file, WAR file, or any other format that you care for with any other compiler that you can have. All right. Now, when this artifact is produced, this is just an artifact. What can you do in this artifact? We are talking about Dockerization. When this artifact is produced, what you do with the artifact is you Dockerize the artifact. Okay, you then Dockerize this artifact, transform this artifact into what? Into an image. You transform this artifact into an image. We are going to transform the artifact into an image. Okay, when the artifact is transformed into an image, What is the process of transforming this artifact from a normal artifact into an image? This is what we call Dockerization or containerization. You can hear Dockerization in some places, and you can hear containerization in other places. Dockerization stroke containerization. Okay, that means now we are taking this artifact, which is supposed to be deployed into, we can deploy this artifact directly into a web server, like what, like Tomcat, like Nginx. Also can deploy this artifact there, but we are taking this artifact and we want to change it from an artifact into an image. So the aspect of changing an artifact to an image is what we call Dockerization. Okay, and how is Dockerization formed? Dockerization is achieved using what we call the Docker file. Okay, Dockerization is achieved using what we call a Docker file, and inside a Docker file, what do? We write commands that are going to take this file and transform it into an image. We write commands inside here that are going to take this file and transform the file into an image. That is what Dockerization is, and that is what we are going to study now. And this file is what we call Docker file. It is always having the name Docker file. Everywhere it is, the name would never change. The name is always a Docker file. So when they ask you what is a Docker file, a Docker file is that file that takes converts an artifact into an image. It might not be an artifact, it might be another image. A Docker file always starts from somewhere. Either it is taking an artifact into an image, or it is taking another image into a more advanced image. Okay, Docker file converts either an artifact into an image, or it takes another image into a greater image. That's what a Docker file does. So what are the characteristics of a Docker file? How is a Docker file written? What is inside this file? How is this file written? What type of things are written in this file? That is what we are going to be seeing now. That is exactly what we are going to be looking at, the characteristics of a Docker file. We have said the first thing is that the name of the file should always be Docker file. The name of the file should always be Docker file. You cannot name it any other name. And it does not have an extension. I remember I was once fumbled and they asked me a question in an interview that in the Docker file, what is the extension of the Docker file? Like in the case of Docker Compose file, the extension is .yaml. But in the case of a Docker file has no extension. You just have it like Docker file. It has no extension. Okay, so this is what we are going to be using in creating an image. So let us go through what the Docker file is all about and try to get everything about the Docker file. So a Docker file, by virtue of its name, is a simple text file which uses predefined, I doubt whether you guys can see me, some people will not be able to see and will not complain. So this is a simple text file which predefined keywords for creating customized Docker images. Keywords used in Docker file are case sensitive. So if I have a Docker file and I want to write the Docker file, keywords are very sensitive. So the Docker file has, just like Adija said, it has some words on the left and other words on the right. The words on the left, how do we call them? Those are keywords used in Docker. They are the main keywords used in Docker, and the words define the various actions that are going to be performed inside that file. Each and every word stands for a particular meaning which is going to be performed inside that Docker file. For example, the Docker file always starts from the word from. That means, where are you taking your source? Because if you want to dockerize something or if you want to containerize something, then something must already be existing. There is something that is already existing. Where is it? Is it coming from a pipeline? If it is coming from a pipeline, what type of a pipeline? What built that pipeline? A Marvin pipeline, then you say from Marvin, right? If it is coming from Marvin, you say from Marvin as build. That is telling Docker that the artifact is coming from Marvin. It might not necessarily be coming from Marvin. It might be coming from another container or another image. So you can say from Nginx. Okay, so maintainer, this is just some sort of a metadata value that says that this container like this is maintained by this person. You can create your image and and write the name of, excuse me, let me drink a bit of water. Okay. You can create your own container and put your name inside as the person who is maintaining the container, okay, or the image. CMD is this is used to specify the initial command that should be executed with the container. So you know, an image is the spark from where a container is executed. So CMD is like saying that during execution, whatever I have precised in CMD should be what is going to be executed and make the container running. Okay, then entry point is the very first thing that will run the container. There is always this confusion between CMD and entry point, and they like to ask it in the interviews. So find some time and really read about CMD and read about entry point and know the differences. Now the entry point can be, you can decide, and the entry point is not the very first point. It's just like it is a point through which the container will execute from. So say use to specify the default process that should be executed when container starts. So when that container will start, the entry point will be the first thing that is going to execute. And then what is a CMD? CMD is that process that will be running immediately that container runs, because if the container runs and finishes and there is nothing running inside the container will exit. So CMD gives a command that will constantly be running. Okay, so what is a run attribute? The run attribute is the attribute that permits you to run Linux command or bash commands. Under the run attribute, I can run things like apt install, I can run things like apt update, I can run things like that. Okay, so let us see a truly Docker file. I once showed you this Docker file some time ago, and I said we are going to come to it. I think this is the right time to come back to it. This is a Docker file that I once used for my pipeline. I think this is a Docker file. So we should go through the Docker file and see what is there and how the file functions. Okay, so this is a file. This is a Docker file. I hope it is visible. This is a Docker file. Okay, look at what is happening in this Docker file. What are we trying to say here? This Docker file, we are saying that Docker from Marvin, that means we have built a pipeline, and at the end of that pipeline we have an artifact. Okay, and the artifact is the build product. Okay, so we are saying that Docker from Marvin as build, that is Docker take the artifact that Marvin has built And then we have another attribute here. This attribute is work dir. They'll always ask you, what is the full meaning of work dir? Work dir is every code that was present in Marvin is going to be sent to this directory. You are the one that is sending that code to this directory. You are creating a directory inside that container. Okay, all the code that has been built will be sent to this directory. All right, and then you are going to say here you are just specifying and creating the directory. Then here now you are copying. When you say copy and you say space dot, that means copy everything in this particular directory, the directory which you are working. Your code will be found in that directory. So you say copy from this directory, and then you are going to send it to the directory app. What I did here was I said copy from this directory to the directory app, and the directory app was also inside this directory. So I just put 2 dots. It's easy. So if you did not want to put 2 dots, you say copy from this directory to the app directory, the directory that you have just created. Okay, you see now that run command. When you use run attribute, you can now execute Marvin or Linux bash command. Say run mvn install. Okay, and then this is what we call a multi-stage Docker file. Very advanced. You will get to it when we start doing multi-stage Docker files. Now we have our artifact that we have already built. We have built this Docker file. We have built this artifact, and we have transformed it into an image, and the artifact is already existing now as an image. Now you see the artifact is going to be deployed in a web server. Okay, the artifact is going to be deployed in a web server. And what type of a web server? We are going to deploy the artifact using Java. Okay, so we have to make sure that Java is present. Okay, so in the second stage of our file, we say from OpenJDK. OpenJDK is what is going to run our Java. Okay, we see specify that we are working in the directory that we created up here. Okay, now we are copying everything that was here down to our app directory. So we are copying everything that we had up here, and now we have a target stroke uber.jar. This one now, this uber.jar is the name of the application that was built. Okay, we are sending it to here. Then we are exposing now that this container is going to run on port 9090. And now you see CMD. CMD means that every time that this container is executed, java-jar uber.jar will be running. This command will always be running. This is a command that keeps the container afloat. Okay, so that is a Docker file. You must learn how to write Docker files. You have to learn how to write Docker files, because at the end of your pipeline will be a Docker file that converts that artifact into an image. So let us try to see in reality how a Docker file performs. So the first thing is that I am going to create a file which I'm going to name Docker file, and then I'm going to write some command inside that file, and then I'm going to execute. Okay, so first thing is let us exit from here. I hope everybody is in line with me. Is the learning steep?
So we are still connected.
Pardon?
So it's not actually too, because I went through.
That's great. When you go through it, it becomes very, very easy, right? Becomes very easy. When you go through it before the class, it's very nice because things get very, very easy. So let me remove my 2 containers that we are running, so that we should start from the base. Okay. Now I want to create a file, so I am creating. We said the name must be Docker file, right? It must be a Docker file. Okay, my file is created and it is a Docker file. So what should I do? Let me say from. It must be in capital letters. Okay, it must be in capital letters. From. Okay, what am I trying to do? Since I have no pipeline, I have no artifact, let me create a Docker file from another image, right? I can say from Nginx. Okay, I can say from Nginx, and then might be I install things inside Nginx, but let's stick with what we have just done. So I say from Ubuntu. From Ubuntu, right? I'm taking the image Ubuntu that is already found in Docker Hub. From Ubuntu, run. I want to run these commands inside Ubuntu. apt get update, right? And then I say again run apt get install git, and then I say again run apt get install Maven, right? This is a very simple Docker file, very simple Docker file. I'm taking my image from Ubuntu, and then I am updating it, and then I'm running apt-get install git, I'm running apt-get install Maven. All right, I save and quit, right? And then I run ls. I will see that this is my image, this is my file, excuse me, this is a file that I've just created. It is called Docker file. So how do I execute this file? This is very important. How do you execute this file that you have just created? In order to execute this file, you have to run the command docker build, right, -t. -t means you are tagging the image. That means you are giving a name to that particular image. So what is the name that you want to give to that particular image? I want to give the name my Ubuntu. My Ubuntu, that is now the name I'm giving to my new image, my Ubuntu. Okay, so when this image will run, when this container is going to run, the name will be given to it, my Ubuntu. Let us make sure that we are okay with what we are writing. So running my container, in your notes I think I used okay, docker run -t my Ubuntu. We are okay. Now there is one thing you should know. This thing worried me, this space dot, if you don't put it, your life is messed up. This very space dot, if you don't put it, this thing will never build. I remember I spent 2 days when I was practicing one day because I was omitting this space dot, and that is when I was already almost close to like a year in my IT career, and I thought I already knew things, and just this space dot in building Docker images gave me a huge lot of problems. So you want to build now the image from here. Have you seen we mentioned anything about Docker file here? We are not mentioning anything about Docker file here. That is why the name must always be Docker file. The fact that we are putting this dot here, space dot here, means Docker will search this particular working directory where we are found. If Docker sees a file named Docker file, Docker is going to enter inside that file and start building an image. That is how Docker works. Okay, we give a name Docker file, so we do not precise the name here. Docker is going to search the working directory. If Docker sees any name Docker file here, Docker starts building that image. So let's execute. So you see Docker is already building the image. It is already running apt install git. It updated here. Error, run apt get install git. So we are having an error with the installation of git. And now it's good that we got an error. Whenever there is an error, the image is not going to be built. Okay, whenever there is an error, the image is not going to be built. You see, it says bin bash apt-get install git did not complete successfully, exit code 1. Question is, why did it not complete successfully? Okay, we try to go through the necessary logs and we try to see things that are happening. Did we run a spelling that was not right? Let's check our working document. So apt-get install git, we are supposed to pass the hyphen auto accept. So let's see if we correct it. So we run ls and we run v docker file, and then we go up here hyphen y git apt-get install hyphen y git. So we save and quit, and then we run the command again. The command Marvin also needed an auto approve, which was not auto approved, so we need to also auto approve Marvin. So we go there again, hyphen y. Let's verify for the command Marvin. Do you have a command Marvin here? Okay, I did not input it there. Okay, let's run it again and we see. Okay, you see our file has run now very successfully and completed. So let's let us try to see, is it going to be alive? Docker container ls. Will you see the container? We are not going to see any container. We will run docker ps -a. We certainly are going to see a container. Okay, that is a container without any name. Do we have a container here? Can't see the container here. Okay, docker. No, we have not yet run the container. we are supposed to be looking for an image, Docker images. Yeah, that is my Ubuntu there. So we can now, we have transformed we have, from a Docker file, we have created an Ubuntu image. So we are not supposed to be looking for a container that is running. We are supposed to be looking for an image which we have created. Okay, now I want you to take a look at something here. We have tag here, nothing, right? We do not have a tag here. So what if we really need to have a tag here? What can we do? So let us go back. Let us destroy the image. Docker RMI. Let's destroy this image. My Ubuntu. Now, if we want to have a tag, this is what we can have here. Okay, here docker build -t my Ubuntu. When you allow it like that, the name will be my Ubuntu, and the tag will just be latest. But if you wanted to build and give maybe let's say version 1.0, 1.0, right? You can give your version, right? Ubuntu version 1.0. Let us run and see. Now it finishes. Docker images. You see, now we have a version here. This is my Ubuntu, and then the version now is 1.0. So you can decide each time you are running your image in the pipeline. When we come to running pipelines, you will see how these images are given tags automatically. So each time a pipeline runs, it is a different version of an image that is being created. Okay, any question on building Docker images through Docker files? We are going to have a lot of Docker files as we go ahead. Any question? I hope people are not sleeping.
No, we are here, sir.
Questions will come.
After,
Questions will come.
after practice.
Yes,
See,
sir.
yes,
Yeah,
sir.
they'll come. They'll come.
All right. Okay, I leave you with this to go and practice the little that we have done, and then try to do more advanced research into how Docker files are being written. Okay, we are going to do just a little bit of more research on how the files are written. I think we are going to take a look at all the various keywords in Docker, which I think I have put them down in your notes. Most of them are here. You should try to learn what each of them does. CMD, entry point, run, user, working dir, copy, add, and this is giving environmental variable, expose, volume, label, stop signal. You find out what all these Docker commands are, and then you see what they are doing. So that's why we call them keywords in Docker. All right, then working with Docker files, then you will see how we can version Docker file. Docker file is a code, right? So we can version Docker file. So after that, now we are going to come to what we call cache busting. Okay, I'm going to come to cache busting. You see what cache busting is, and then we'll talk about public registry and private registry. This is just public registry is just Docker Hub, right, where you can put all your containers, all your images in Docker Hub. And then private registry is how you can create your own registry to be storing your own content, your own images. Okay, so we are going to come to all these in our next lesson. All right, In case of no questions, I allow you guys to sleep. I think those in Dubai are already more than past midnight. Let's not pull it that much, okay?
Okay, so that's true.
Okay,
Okay, sir.
alright. See you guys tomorrow.
I want to see it.